Hey guys, this is test 37, game 4. This is the swim relay race game. It's an ordering game. We know this because the laps are numbered 1 through 10, and we have the rules referring to before and after. So I've laid out a bunch of stuff here, but I'm going to explain all of that. Basically, because we know that the same person does 1 and 6, the same person does 2 and 7, 3 and 8, 4 and 9, 5 and 10, rather than laying things out 1 through 10 horizontally, left to right, instead, I've chosen to represent things 1 through 5 and then again 6 through 10, meaning that whatever the ordering is for 1 through 5 will be the exact same ordering for 6 through 10. So you could kind of imagine an arrow going up and down here, top to bottom vertically, to indicate, if you like, just to remind yourself that 1 and 6 will be the same person, 2 and 7 will be the same person, etc. Now I've laid out the other rules as well on the left. I'll explain those as well. We know that K is never immediately before L, so I've drawn KL in a box with a slash through it, meaning they never occur in that particular order. Next, we've got that J is not on 9, so if J is not on 9, that means J is also not on 4, because whoever does 9 also does 4, and vice versa. We've got that O is at some point after M, simply telling us that M occurs before O. Finally, we've got that at least one of the J's occurs immediately after one of the O's. So we have an OJ box occurring in that order adjacent to each other at least one time and maybe 2 times. So I've drawn 1x/2x just to tell us that it occurs once or twice. Now, how could that only occur once, right? I mean, if everything repeats and OJ was on 1, 2, let's say, it'd have to be again on 6, 7. There is one way that the OJ box could only occur once. That would be if O was on 5 and then J was on 6, because then J would be on 1, 6 and O would be on 5, 10, and that box would only occur once. So the thing to keep in mind with this diagram's one drawback in my opinion, is that it does not represent the OJ consecutively on 5, 6 possibility very neatly. But other than that, I believe this diagram is superior to simply listing things 1 through 10, so I've chosen to use this particular style in diagramming this game. Now, this is the initial setup, but there is a great deal we can do in the way of inferences here. Because if J is never on 4, 9, we know that O can never be on 3, 8, because whatever occur, if O was on 3, 8, then J would have to be on 4, 9, which we know is impossible. Additionally, because M must occur before O at least once, we know that O can never be on 1, 6, because if O was on 1, how could M become before it? So for that reason, O can't be on 1, 6, and M cannot be on 5, 10, because if O was on 10 and 5, then we would not be able to have the first O coming after the first M. Now, if O is never 1, 6, we can also infer that J is never 2, 7, because if J was on 2, 7, we'd have to have O on 1, 6, which is, of course, impossible. So you see here that we have a restriction for every single variable, for every single slot in this game. We know that O is never first, J is never second, O is never third, J is never fourth, and M is never fifth. And this serves as a pretty good initial setup for the game. We can simply jump in using this. So anyway, question number 19, typical orientation question. You just want to take one rule at a time and apply that rule, or inference of course, to all 5 choices looking for violations. So I want to use these restrictions OJ, OJ, M for 1, 2, 3, 4, and 5, checking for any hits. So I count off OJ, OJ, M for choice A, no hits. Count off again OJ, OJ, M for choice B, and we do get some hits. We have O on 3, J on 4. Of course, that's impossible. You see that O can't be 3, 8, J can't be 4, 9. So for that reason, choice B is eliminated. Again, we count off OJ, OJM for C, no hits, OJ, OJM for choice D, and of course we do see O on slot 1 for D. That's bad, therefore D can be eliminated. Again, counting off OJ, OJM for E, no hits. So we've exhausted the usefulness of these restrictions here. Now I would move on to the rules themselves. Do we have any choices with KL occurring consecutively in that order? Yes, we do. Choice E has K4L5, unacceptable, so E is eliminated. We also know that we have to have M before O, So looking at A and C remaining, do we have that? Looks good there on that count. But what about the OJ rule, that O and J have to occur consecutively in that order at least once? A actually works because it has O on 5, J on 1. So if J was on 1, J would have to be on 6 as well, making O on 5, J on 6. So that works on that issue, whereas choice C has O on 5 and then would have L on 6. Unacceptable, so C is gone, leaving A as our answer for number 19. Next, number 20, if J was on 8, for how many laps can we determine the assignment? So if J's on 8, we know, of course, that J also has to be on 3 because 3 and 8 are the same. We have to have an OJ box at least once, so we're going to have O on 2 and 7. Then since M is before O, M will be on 1 and 6, forcing K and L to go on 4, 5, 9, 10. Of course, KL cannot go in that arrangement, in that order. They have to go in the other order, L on 4, 9, and K on 5, 10, due to that rule. So it turns out that every single variable is placed, every slot is fully determined, so all the labs are determined, and we know that then choice A, all 10, is our answer to number 20. Next, number 21, if O was on 4, what could be true? So if O is on 4, of course, it's also on 9, and the OJ box requires that J be on 5, 10 in this case. Of course, nothing else is determined. You know, we got K, M, and L open-ended on 1, 2, 3, 6, 7, 8, as long as we comply with the KL box rule right here. So what could be true? J on 1, no, J's on 5, 10. J on 3, again, J's on 5, 10. K on 5, no, J's there. L on 3, yeah, maybe, seems good. I'll look at E though. M on 5, no J's there. So D is our answer for 21. 22, general could be true question. Could J be on 4? No, we have a restriction there, of course. Initial rule, A is gone. Could K be on 5? Yeah, we actually saw that just now from number 20. If J was on 8, we had L on 9, K on 10, and then of course K was also on 5. So B works and is good, our answer for 22. Next, number 23, where can't J go? It can't be on 2, 4, 7, or 9 due to initial inferences and restrictions. We see B lap 2, so we've got a hit and we're good. Number 24 is a general orientation question, just like number 19, only this one is referring to laps 6 through 10, but same exact general idea, same exact approach. So I'm going to look for hits for OJ, OJM on 1 through 5, 6 through 10. So counting off and looking at A, OJ, OJM, no hits. Looking at B, OJ, OJM, no hits. Looking at C, OJ, OJM, no hits. Looking at D, OJO, yes, we've got a hit with D. We have O on 8, unacceptable. O cannot be there. So for that reason, D is gone. And then E, of course, hits OJ, OJM by having O on 6, J on 7, which is impossible. So we got rid of 2 off the bat. We can now use the rules themselves to get through the rest. I'm going to start with the KL rule right here. We see that B has KL occurring consecutive in that order. Unacceptable, so for that reason, B is eliminated. Next, we could use the M before O, but A and C both comply with that. Finally, we could use the OJ box rule, and we see that A violates that, having O on 9 and L on 10 unacceptable. That would not allow OJ in that order as a block to occur. So for that reason, A is gone, leaving C as our answer for number 24.